Okay, I think Addie just left. Is she here?
Sorry, I think my Google Meets is cutting out a bit, but I believe I'm back.
Okay. Okay, can you see? Okay. Hi, everyone. Today we're going to be presenting on alerts for the core team. So generally speaking, alerts allow users to be notified of changes on objects. Currently, we have 9 different types of alerts, and these alert types represent what kind of change the user will be notified of. So we have alert types like events, financial data, limit, etc. And we can break down alert types even further into limit alerts and system alerts. So limit alerts are triggered based on user-defined threshold crossings, and system alerts are triggered based on like state changes or new data, etc. And we differentiate between the two because they have different parameters and different behavior. And Addie will touch more on this a bit later. So how do these alert type and object type concepts translate to our model infrastructure? We have one model for each valid alert type and underlying object type pairing. So each model is responsible for maintaining its own state, evaluating the trigger, and providing access to the underlying object. So in this alert type and object type to model map, you can see that we have 3 object types that have fundamental score alerts, those being company, model portfolio, and watch list. And what I mean by valid pairing here is that not every alert type makes sense for every underlying object type. So for example, it wouldn't make sense for an investment strategy to have a fundamental score alert because only stocks have fundamental scores. So you might look at this map and wonder why model portfolios and watch lists have fundamental score alerts when the underlying object doesn't have a fundamental score. And this is where the concept of single versus composite alerts come in. So single alert models are models like company fundamental score alert that you can see here. They trigger based on the underlying object itself, whereas for composite alerts, we're alerted on changes in its items or its holdings and not on the object itself. So to achieve this, we have, or each composite alert has a corresponding alert item model, as you can see here. And alert items have a one-to-one relationship with the model portfolio item or a watch list item. So you can kind of think of alert items as like belonging to the parent alert. And this parent alert is responsible for the creation, deletion, essentially the synchronization of its alert items to its underlying objects holdings. I also wanted to touch on a model refactor that is currently ongoing. So previously, I mentioned that we have one model associated with each alert type or underlying object type, and we didn't really have any base classes that these models would inherit from. And this meant a lot of code repetition. There were also some inconsistencies across models. So for example, some models would have a security property method defined, whereas others access the underlying object using the foreign key property directly. And this led to a bunch of issues with polymorphism when we tried to treat the alert instances uniformly when we were implementing the alerts manager. So we decided that a model refactor was definitely necessary. And what we wanted to achieve with the refactor was to increase code reuse and increase model consistency. And our solution for that was to deconstruct models into its object type logic and its alert type logic. So we did this by introducing several base classes that are inherited by each alert model. Using fundamental score alerts as an example again, you can see that we have an abstract alert base model that acts as the interface for all alert models to help with consistency. And we also added abstract object type models for every object type. And these object type models will all inherit from alert base. Each object type model defines its object specific logic. So this is stuff like accessing the underlying object, and it also contains the foreign key to the underlying object. And then each alert type model defines alert type specific trigger logic. So like this fundamental score alert base contains logic that determines if a fundamental score has changed for a company. And then we have the concrete alert model, so the company fundamental score alert model that inherits both its object type model and its alert type model. For composite models, it's a similar structure to the single alert models, except we also have this alert item base. Here, the concrete alert item base inherits from its object type alert item base and its alert type base. So the reason that the alert item inherits from the alert type base rather than its like parent alert inheriting from the alert type base is that the trigger logic is determined from the item or the holding rather than the watch list itself. Yeah, so we also have a few other models that don't necessarily model alerts. One of them being alert messages. This models the user-facing message when an alert successfully triggers. It's also displayed to users in the alerts module on the dashboard and emailed to users depending on their set email frequency. We also have an alert log model, and this model enables tracking of an alert's lifecycle, and an instance is created at each point of the alert's lifecycle. So creation, deletion, alert message creation, etc.
So I am going to be going over some of the trigger logic that we have and the differences on how we trigger different types of alerts. So just to review a little bit of what Eliza mentioned, we can divide alerts into two groups. System alerts, which are triggered by the changes in the data that we have on the back end. This could be something like getting news articles for a company. And we consider all the alert types that aren't limit alerts to be system alerts. And limit alerts are triggered when a value crosses a threshold that the user specifies. Next slide, please. So I'm going to be talking a little bit about triggering limit alerts. Limit alerts run on trigger logic that's actually pretty different from system alerts. It does get a little bit complicated determining when these alerts should trigger. So let's say we want to know when Apple's price is higher than the average, which in the past couple of days comes out to $147.99 or $148. So we set a limit alert to tell us when Apple's price is higher than $147.99. So as you can see from this beautiful chart from YCharts, you may have heard of it. On October 24th, the price goes up to $149.51, which triggers the alert and sends us an alert message. On October 25th, however, the price goes up again to $152-ish. And while this technically satisfies the condition of being over $147.99, we already triggered the alert before, and we don't really want it to trigger it again since it doesn't really tell us any valuable information. So how does the alert know not to trigger until it crosses that threshold again? So rather than the alert telling us if the price is over the average, we're actually asking, is the price over the average, and was it previously under the average the last time that we checked? Next slide, please. And so essentially what we do is every time we check if the alert has been triggered, we save the value in a field that we can check against the next time to see if the threshold has been crossed. So in this case, the alert can only be triggered if the last price value we compare it against is lower than 147.99 and the current value of the price is higher than 147.99. In the table, you can see that in this scenario, it would trigger on October 24th and 28th, since that's when both of these conditions are satisfied. Also note that the target value is not always a static number and it can change since users can actually select to compare against a different metric. Next slide. So triggering system alerts. We can actually further divide system alerts up into two alert types that Eliza previously mentioned, single and composite alerts. Single alerts are the simpler of the two and reference alerts that don't need alert items. So these alerts are meant for securities like companies that don't hold other securities. So the image to the right shows a shortened version of the trigger alert function, which is called in the alert base class. And this is where all of the main logic for the single system alerts happens. So the general logic of the function is it checks to see if the alert was already successfully triggered that day, and if not, it calls the evaluate trigger function, which is implemented on the individual alert models. So this is where we would check for like news data, financial data, etc. So if the evaluate trigger returns true, we create alert messages to send out to the user and then update the state of the alert. Next slide, please. So composite alerts are slightly more complicated since whether or not these alerts get triggered depend on whether or not their alert items are triggered. So for example, a model portfolio news alert would check to see if any of the model portfolio items have new news articles. So just going over the general structure of how composite alerts get triggered. So first we have to synchronize the alert items, which is super important. If there are new holdings added to the model portfolio, this is where we create new model portfolio alert items for them. So then we call the trigger function on the individual alert items. And in the alert item trigger function is where we create the alert messages if necessary and update the state of the alert. Next slide, please. So like I mentioned earlier, whenever we call the trigger function on a composite alert, we always want to make sure that the alert and alert items are up to date with the underlying securities items. So for example, when we add or delete a watch list item in a watch list, we want our watch list alert and alert items to reflect this change. Oh, yeah, and what we did is we implemented a method called synchronize alert items on our model portfolio alert and watch list alert base classes. That searches for the model portfolio or watch list items that don't yet have alert items for, and we create them. So we actually have cascading deletion set up on watch list alert items. So we don't really have to worry about if a watch list item is deleted or unshared. But since we have model portfolio items and dynamic model portfolio items, we used a generic foreign key for the model portfolio alert items. So we can't use the cascading deletion. So we had to set up a pre-delete signal for model portfolio items and dynamic model portfolio items. So this way, our alert items will always continuously be in sync with the model portfolio items. Next slide, please. Last thing I want to touch on really quickly is how we actually queue up alerts to trigger. We have a handful of management commands that run throughout the day at a specified time or time intervals. They could be anywhere from once a day to every couple of hours or every 10 minutes. So these commands grab all the alerts of a given type and then create a celery task for each individual alert. And then the Celery task gets queued up in the alerts queue and eventually calls the trigger function on each individual alert. So alert and alert items are saved indefinitely until they're deleted by the user or through signals or cascading deletion. Alert logs and messages, however, are deleted after a year. And I think next Eliza is going to go over the Alerts Manager project.
So now that we've covered a little bit more about how alerts work, we can talk more about the implementation of the most recent Alerts Manager project. So on the back end, the Alerts Manager follows the existing structure of similar pages, like the model portfolio list page. We have a page params class to model the params needed for the list page. And this class is responsible for creating and cleaning the params that we get from the request. And we also have an alert list page service class that gets and filters the alerts based on the params. On the front end, to manage the state of the alerts manager and store state in the URL, we use the alerts list app state service. And we also use NGRX state to store the filters and coordinate modals opening, etc. So we had some notable challenges during the Alerts Manager project. The first one being filtering alerts, and I kind of touched on this a little bit previously, but because we had so many different alert models and a lot of them had inconsistent underlying object access and properties, this led to poor polymorphism, and it made it difficult to filter alerts and treat the different alerts uniformly. So we actually had to go in and add a bunch of property methods and update serialization methods individually because there was no parent class. And this is a huge part of what motivated the refactor. We also didn't really have a way to represent a group of alerts. So we would use the term alert or alerts interchangeably between a group of alerts for an object and a singular alert. So this is also reflected in the views for alerts. We had the same endpoint being used to get a group of alerts and a singular alert. Similarly, we had one endpoint being used to delete a group of alerts versus a singular alert. So that made the code really messy and difficult to read because these operations all require different inputs. So all of the view endpoints have a bunch of optional parameters, and we're definitely planning on refactoring this after the legacy dashboard is retired, but that's the only place that's still really using them. And then also with the alert edit modals, so different underlying objects require different edit modals. They require different metric search types. Some of them have different system alerts. So we need to open the correct modal depending on the detailed underlying object type. But the issue here is that when we open the modal using an autocompleter result, we did not have the detailed object type. So previously we had a param called alert metric search type in the autocompleter. And we couldn't use this existing param for a few reasons. So the first being when we added model portfolio alerts, that did not have the alert metric search type param in the autocompleter. So we wanted to avoid it reinitializing it. And we've also updated the alerts autocompleter to include watch lists. So our solution for this was after getting the object from the autocompleter, we make a call to the backend to determine the detailed security type or the watchlist type, and then we open the modal. So in the future, we are planning on adding notes. Similarly to how users can add notes to securities, you'll also be able to add notes to alerts. However, notes on alerts are not going to be shareable because the alerts themselves aren't shareable. We're also going to be adding editing functionality to existing limit alerts. We currently don't allow limit alerts to be changed once they're created. You would have to delete and then recreate them. And then we're also adding the concept of a one-time alert. So an alert that triggers one time. This is specifically for limit alerts, by the way. The limit alert would trigger one time and then go into kind of like a stale or dead state. And we are also planning on adding new system alerts. This could be a combination of some existing system alerts that aren't being used as much, but product is still fleshing out the exact requirements for those. And that's all. Any questions? Ezra?
Yeah, it was just when Eddie had that price chart, those are all end day prices, right? Closing prices. This isn't related to intraday at all?
That is correct. I think in this case, yes. Matt?
Yeah.
Yeah, it seems like if you're tracking the differences in prices, like for instance here, day by day, for a single alert, and then you're tracking, okay, did it trigger the alert today, and then tomorrow, does it trigger it again based upon yesterday's price? It seems to me like that data already exists elsewhere. Was there an advantage to storing that specifically with regard to the alert in order to determine whether or not it was triggered? It seems like there's a lot of data that's generated as a result that would be possibly redundant. Am I wrong by thinking that?
Sorry, wait. Just real quick, a clarification on that chart. It
Yeah.
is close. Those are the close prices, but I believe when we, and correct me if I'm wrong, but when we check like intraday, you had that Eliza, you had up, I think, or Addie, you had at that those different management commands, like the intraday, we check every 10 minutes, we queue them up. I think we do check like the current quote price if I believe, I think we do, which is why we trigger them every 10 minutes to see like, did it change, over the course of an hour. Matt,
Yeah, I do believe that's correct.
Matt, I didn't understand. Sorry,
No,
Matt,
you
I
go.
didn't understand the question. Can you ask that question again?
Yeah. So if you go back to the there was one slide that had like the Y and N on it for each item there that says whether or not, yeah, right there. So I guess what I heard, and maybe I'm wrong, was that for a given alert, you tracked, okay, did it already go over that value? And is it smaller than the target value? For instance, October 24th, right, where it's Y and Y. Are you storing the results of that check, or is this a check against the data that says, oh, we have that price from yesterday? I guess what I'm wondering is,
yeah, no, I
is
think I understand.
the result of the alert tracked and stored every time it's checked?
Like, are you asking if we're tracking if it's been triggered, or
Yes.
well, we have every time the alert is triggered, we set the last trigger date. So
Okay.
in
Yeah.
that regard, we are, yeah.
Is it tracked if it's not triggered?
We update the state if it's not triggered. So for example, like this last base value would be updated, but last trigger date wouldn't be because it hasn't successfully triggered.
Okay, so there's not some long log of things. It's basically just updating that object. So
Yeah.
okay, disregard.
Yeah.
Cool. Thank you. Thank you, Jake. Got it.
Yeah, and just on this topic, it's existed for a long time. We're obviously not like a trading application. So like a shortcoming that one could argue is that, we check every 10 minutes, right, for Apple's price. Well, if you have a threshold and we check, 10 minutes before and it's below that threshold, and then it goes up above that threshold and down below that threshold and up and then down, and then we check again after 10 minutes and it's still down below that threshold, we're not going to tell you that the alert triggered. Um,
Yeah, it's
where
down to sampling rate at that point. Yeah. okay.
exactly. Yeah. And we're not, yeah. So, we certainly aren't, and no one's using our tool to, obviously execute a trade like intraday. That's just not what YCharts is supposed to be doing. So there is that shortcoming, but obviously for 99.9% of cases, that's we kind of cover that,
Cool.
cover like the functionality. Yeah. And if you wanted to do that, in theory, you'd have to, Matt, to your point, you would have to, sorry, not to harp on this, but you'd have to look kind of historically, if you had streaming data or like your quotes, you would have to look basically over the last 10 minutes and see, did it go below and above in that 10-minute period that you didn't check before? But we definitely don't do that.
Any other questions? Cool. Thank you. Thank you, everyone.
Thank you both.
Thank you.
Thanks.
Great presentation, guys.
Adios.
Thanks.
Thank you.